A stone is thrown vertically downward. It means that its initial velocity is not zero, and its initial velocity is some value that is negative, and it is thrown downward without an atmosphere from the cliff. So without an atmosphere means that there is only one force exerted on it. For example, if this is a stone and there is only one force exerted on the stone, that you know very well is the force of gravity, which we also say weight. So due to the weight, this stone will fall freely. That's why this is a question about the free fall motion. And what will be its acceleration? That will be due to gravity, negative 10 meter per second square, that we can use in this MCQ. So when the stone was thrown initially, you know that its initial velocity will not be zero and it will be some value that is unknown. But when it was falling down, its velocity will increase due to force of gravity. And we know about the two positions. At two positions, its velocity is given. So its velocity at this point, let us consider, if we take it as our initial point, then it is negative 11 meter per second. I'm saying this is a velocity, right? It's not a speed. Speed will be positive value, whereas at this point, if we consider its final point, so then it will be negative 23 meter per second, and negative is due to the downward direction. Okay, so I'm just taking this initial and final point because I want to use this data to calculate acceleration. Okay, and what will be its initial speed, we will find it later. Okay, so what is acceleration? Acceleration due to gravity is actually also the rate of change of velocity. Okay, so that means that it's a v minus u over delta t is the time taken. So it was a time 1 second when its velocity was 11, and this is a time 3 second. So you can see in only 2 seconds the velocity increased from negative 11 to negative 23. So if we put value negative 23 minus into negative 11 divided by 3 minus 1 is 2 seconds, and unit is meter per second square of acceleration. So then it should be, and acceleration is equals to negative 6 meter per second square, and negative is once again because the acceleration's direction is downward, that's why it is negative, otherwise its magnitude is positive. Okay, now the what is the initial speed? So we can apply any Suvat equation depending on the data. So if you want to find initial speed, the speed at a very beginning, now I am considering it as a initial point, and this is a final point, or you can consider this one as also a final point, final position. So this equation is a most suitable because now we know acceleration as well. So final speed, if you consider 11, so I will write negative 11, that's the velocity, is equals to initial velocity is unknown plus acceleration is negative 6, and the time, how much time elapsed, that is 1 second. So that it means that negative 11 is equals to u minus 6, and u is equals to negative 11 plus 6 is equals to negative 5 meter per second. Don't go anywhere, I'm also going to show you the speed time, velocity time graph in fact. Since it's a free fall motion, that's why acceleration is constant due to gravity on that planet. That's why the graph of velocity time must be straight line, and it will be, the shape of the graph will be like this because it is starting from what value, negative 5 meter per second velocity, and it will be negative 23 value as it is going on at how much time, at the 3 second it will be negative 23 meter per second. So the answer for this question is obviously A,